Hey, this is Steven from the Green Engineers, and I want to do a quick video showing you guys one of my prototypes here of my plastic shredder, known as the Reclaimer. So this is a plastic shredder of my own design, and these are becoming ever more popular with companies or communities out there like Precious Plastics by Dave Hackins. So these kind of shredders are becoming very popular. So those guys have their own shredders, but this is of my own design. I just got it back yesterday from my university. My university just got in a really nice 4-axis pan and tilt Maxim water jet. So basically the head could pan and tilt in order to compensate for the taper that's in the inside of these squares here. So I wanted to show you guys this. I'm going to be working on a machine here at my house here to or home base to start working on this, because as you guys know or have seen on my website or Facebook or on one of my blogs, Tech Shop went under recently. Tech Shop was my old headquarters, but they unfortunately went out of business November 15th, and they have yet to open, and they probably will not reopen for a good time soon. So unfortunately at my university I could only now use it, and it's going to be my main place of prototyping, but I could only use it as a prototyping location. So I will be working on building a small compact plasma cutter here at home base. And that will be, I will start putting that together here pretty soon. I'm going to get the steel today, actually. Going down to Sims Metal Management, talk to my buddy Julian to pick up some steel for that guy so I could start building the frame. And that's going to be a Gerbil powered, otherwise known as an Arduino powered CNC plasma, using a cheap Cut 50 from China. Hopefully I could punch out parts like this or close to this that just need to be hand finished, and while that's happening I could work on other things because it's CNC. Alright, so the blades here, so these are two different materials here. The blades and some of the other parts are made out of 1055 steel, which is hardenable steel. So 1055, it has enough carbon to be hardened, and the other parts are like these are A36. You guys can see that it has a very different top finish on it, and these also have like an anti-corrosion finish on it. This red finish is like an anti-corrosion finish. So also these gears are also 1055. I have a set of 1055. These are built using Fusion's gear generator, and I just wanted to test it. Probably wasn't the best idea, but these were set to 0 backlash, and as you see they're pretty much almost exactly perfect. They're pretty much exactly perfect gears. They have so little backlash that they kind of tend to get stuck. So hopefully they kind of wear into each other and become a little bit more smooth. So that generally I'm not going to run for the most part, because this is not a precision machine where I need 0 backlash gears. But I was just testing to see if the Maxim water jet at San Jose State University would be able to generate 0 backlash gears for precision linear movement, which, as you can see, it can. With 1/4 inch, these are all 1/4 inch plate. The entire shredder is designed to be cut out of one type of plate, either 1055 or A36, or 1055 and A36, all out of 1/4 inch. So these are the cutter blades. They're all 1/4 inch, and the shredder itself, its dimensions are 6 inches by 6 inches by 3.5 inches tall. So a 6 inch by 6 inch total cutting area, but obviously from blade tip to blade tip it's smaller. It's maybe 4.5 inches or so total cutting area. So it'll cut. The idea was to be able to cut, you know, from head to tail a milk jug, right? Because that's one of the more popular things that you'll find. So I wanted to at least be able to do that. And so in order to do 6 inches across, you need 25 shredder dowels. And I noticed yesterday that my buddy at San Jose State that does the cutting, and also the cutting was through my club, San Jose State Maker Club, which I'm the president, which we're going to specialize in doing stuff for doing things like this where somebody wants to prototype because they want to go into business after school. This would be what my club would specialize in. So through that, San Jose State will help us out with machining. Unfortunately, what I didn't notice at the time that I had him cut it was that he made one mistake, and that mistake was that each of these are actually supposed to be progressing blades. So they're actually supposed to be like slightly, I'll zoom in here in a second, so they're kind of supposed to do that, where the first blade is going to contact, and then the second blade takes a few more rotations before it contacts, and then the next blade, and then the next blade. But what he did is he made them all the same angle. So basically what it's supposed to look like is this interior square is supposed to be rotating. But what it looks like is he just cut 24 copies of this internal square. So this square is not rotating, so all the blades will contact at once. So the only thing I could do on this now to kind of, because this is a hand-driven shredder, it's going to be very difficult to do that. So to have cut a material all at once. So what I'm going to do is I'm going to just do the 90-degree rotation. So half of them are going to be this way, half of them are going to be this way. So at least we have 90 degrees before another set contacts first. The next set contacts. So have them kind of have this alternating contact. But what that means is you'll have a cut, and then you have to progress 90 degrees before you can cut again, which might be super annoying. And then we have these guys, the spacers. There's also 24 spacers. These guys are cut out of A36. Again, same plate, 1/4 inch. And these accept a both of these, everything in here that has a square hole accepts a 3/4 inch drive shaft, which here's one of them. You need two. The other one's in the garage. So this guy is made out of 1045 steel, and it measures about 0.747 inches, and it's really nice. This supplier is really good because this is on a water jet, and the water jet has a radius to the cutting tip. I had to knock out the edges of this guy because this guy had nice square edges, so I had to knock that out with a file in order for it to slip in. And that's why I have two sets, one set here, one set here. These ones need a little bit of work on the interior where the water jet made some mistakes. So I'll have to go in there and file that out a little bit. All of these fit, and pretty much all the dials fit except for these two. So let me go ahead and show you a fit on here. Let me turn it around because I have the camera in my other hand. And hopefully this is heavy enough that I can just slide this on here. And there it is. So yeah, basically it just slides together like Lego pieces, and then when you put it together, these side plates just weld on. So that way you could adjust for any sort of change in thickness, especially with this A36 having this rough edge. And the final pieces are these. I call these half moons because it's got, you know, half moon here. I don't know exactly what these are called technically, but basically what these do is these ride on the spacers like that. You can see one thing from the process is that there's a tab right there. This is to keep the part from falling into the water bath and falling all the way down and into the garnet to never be found again until you clean it, right? So those are going to have to be filed off. It should take a few seconds to file those off, really tiny. But as you see, it rides in there, and you can see how little the kerf is. I'll explain what the kerf is, but that's the gap there. So this is really tight. So basically what happens is you have this guy, and then a shredder dowel goes over top, like that, and then when the shredder dowel is rotating, this will knock, well, it's going to rotate inwards, right? It's going to rotate inwards like that. So this prevents any plastic from going around and going down past without being cut, unless it's this size and it can slip past. And then if it is, it's okay, it's already been cut. The other thing is when it's coming around, it'll knock the plastic off the tooth to make sure that none gets past, because there's going to be another one on top like that, right? Oops. Like that. So it's going to knock the plastic off and not let it get stuck in the blades and keep going around forever. It's going to make sure it clears it off. So this is kind of what it looks like when it's assembled. You just have these guys alternating like that. Then obviously on the final version, these are going to be progressive teeth. So you have, you know, a set where they do, I think it was like 15 degrees rotation. And you have two duplicates, one on the side, one on the other side. And then so every time you, as you're turning, every single like 15 degrees of turn, you're cutting. So very, very little turn, you're always cutting, and you're only having engagement of one set, so two teeth at once. And so you have the minimal force requirement, so it's very easy to do by hand. This is going to be very difficult by hand because we have multiple of these guys engaging at once. So let's talk about the last piece, which is the sides. So this is out of A36 steel, structural steel. And these are two side plates which are blank. These are going to have 4 holes in it. I've yet to find out where I'm going to drill those, but that's for attachments. Top 2 sets of holes are for the hopper. Bottom 2 sets of a hole are to bolt it down to a table or bolt it down to a stand that you'll make or I'll make in the future. I'm probably going to make a kit for the stand in the future if I finish the plasma here pretty quick. Then you have the front and the back are identical. They take 2 giant bearings in here, and then basically what happens is you have a spacer, sort of like the spacers here, that will turn this square shaft into a circular shaft, theoretically speaking. And then that will fit inside of the bearing, like so, and it will bear on that surface. Right? So the bearing will push in here. The bearing that I'm looking at is half an inch thick, so probably what I'll do is I'll have Kyle at San Jose State cut me another piece here, and it'll go on top so that you can just press the bearing in there and then weld that second plate down. So pretty much like that, right? But maybe not the full steel like that. And so it's going to look like that, and then you press the bearing in there and you're good to go. Alright, so this guy just needs a welding and put it together. Some pieces need to be filed down to fit properly, and then put it together. Obviously all these tabs need to be sanded off because they're going to affect the operation of it. And then mess around with it till these gears get set with each other, kind of wear down a little bit. And then we're going to go through the process of hardening these blades to be able to cut even harder plastics. And then maybe even mess around with trying to mount a motor, and then developing the top, the funnel, as well as the stand with these 2 bottom holes and these 2 top holes. So that's pretty much it. It's pretty much all the parts here. Pretty much 24 count for most of everything. 24 half moons, 24 spacers, 24 cutter dials, 2 gears, and 2 shafts, 2 front plates, front and back plates, or 1 front, 1 back plate, and 2 left and 1 left and 1 right side plate. And yeah, that's pretty much it. So I just wanted to, oh, also here I have another set of blades made out of A36. So that's pretty much it for this video. I just wanted to show you guys the process of this prototype here for my reclaimer. And hopefully I'll do some more videos like this here coming up in the future. And that's it for now. I'll see you guys in the next video. Please subscribe for more content when it comes. And I'll see you guys in the next video. Thanks for watching. Take it easy. Peace.